Greetings. This first screencast is about simplifying algebraic expressions. So let's get into it. Now, this big piece of mathematical stuff you see in front of you, we call that an expression. So it's basically like a mathematical statement. Okay, so all of that together, we would call that an expression. Now, an expression can be made up of many terms. Now, in this particular case, each of these is known as a term. So 3x squared. Now notice here, 5xy, that positive is included. So positive 5xy is a term. Negative 2x squared is a term. Positive 4x squared y is a term. Negative 3xy is a term. And positive x squared y is also a term. So each of these is known as a term. Now, you'll notice that each term consists of a numerical part and a letter part. So just to perhaps ask you to think back to your earlier mathematics, the letter part, this part here, in this case here, that's called a pronumeral. So x is a pronumeral. Y is also a pronumeral. And there are no other pronumerals in the expression. It's made up simply of x's and y's. Now, if we see a number of terms which have the same set of pronumerals raised to the same power, we call them like terms. So let's have a closer look at that. So I'll just change color here so it stands out. That'll be okay. We'll go with that. All right. So we can see here is an x squared term. This term here, actually, I'll try that again. This term here, sorry, I'll try that one more time. Make it a bit smaller. This term here, that's an x squared term. Over here, there's another x squared term. There are no other x squared terms in this expression. Those two terms there we refer to as like terms. So any two terms which have the same pronumeral component or the same letters raised to the same power, they are called like terms. Alternatively, you can also see, hopefully, that here's an x squared y term, and here's another x squared y term as well. So they also are like terms. If we had a look over here, we can see that there's an xy term here, and there's another xy term here. So they are like terms. So we need to be able to identify like terms. Okay. So we'll just perhaps label that. So for example, those two there are called like terms. Now, one final point before we actually go into simplifying expressions. You'll notice that the numerical component out the front, in this case there's a 4, or positive 4 actually, that's called the coefficient. So any particular number in front of the pronumeral part, we call it a coefficient. So the coefficient to this xy term here, the coefficient is positive 5. The coefficient to this x squared term here is positive 3. The coefficient to this xy term here, would be -3. So the coefficient is the term or the number in front of that term, the number in front of basically. Now, when we get to more advanced algebra, you will learn that coefficients can also be variables and pronumerals as well, but we'll get to that later. At the moment, we'll consider the coefficients just being in the form of numbers in front of the term. Okay, so let's get rid of all of that, and let's now simplify our expression. If we wanted to simplify this expression, what we need to do is group them into like terms. Now remember, our like terms, we'll just show them again so that we can clearly see them. The x squared term there's an x squared term here, and there's an x squared term here, and there's no other x squared terms, so they are like terms. So one really good thing you could do is, before you simplify, is to identify and somehow color code or separate them so they're easily seen, the different like terms. So here's the xy, here's one term, xy. There's another xy like term. So that's a set of like terms. And we'll perhaps go with this color. So x squared y, there's a term. There's another x squared y term there. Okay, so they're our like terms. So what we would do is, in fact, rewrite our expression so that our like terms are grouped together. So I'm going to rewrite this expression as, I'm going to look at my x squared terms first. It's going to be 3x squared, that's that like term, minus 2x squared. So I've taken care of both of those. Now I'm going to look at my xy terms. Plus 5xy, and then minus 3xy. And then finally, plus 4x squared y, plus x squared y. Okay, so you can now see that I've grouped them. There's one set of like terms, there's the second, and there's the third. Now I can easily simplify them, because like terms we can add or subtract very easily. So for example, 3 lots of x squared take away 2 lots of x squared would be 1 lot of x squared. So that simply is x squared. Just like 3 bananas take away 2 bananas would be 1 banana. 3 cars take away 2 cars would be 1 car. Well, 3x squareds take away 2 x squareds would leave us 1 x squared. Remember, if it's just 1, we don't need to write the 1 in front. We just assume if there's no number in front, we assume the number is 1. So we'll just get rid of that 1. We don't need that. Okay, let's go to the next term. We've got 5xy, or positive 5xy, take away 3xy. So 5 take away 3 is 2. So it's going to be plus 2xy. And our final set, on the right-hand side, we've got positive 4x squared y plus 1x squared y. So 4 plus 1 is 5. So that will equal 5x squared y. And so our final solution will be, or our final simplification will be, x squared plus 2xy plus 5x squared y. Notice that we cannot simplify those together or add them together because they are not like terms. So that's as far as we can go in simplifying. Okay, thank you.